Greetings, Earthlings. This is Mrs. Wolf coming to you from the comfort of my couch, which is why my camera is definitely not on today. Just wanted to teach you some new information or some old information, whichever it is, about energy and transformations of energy. So, when you think of energy, you can close your eyes and you might think of lots of different things. Some things that come to my mind is my crazy 3-year-old niece who's filled with energy. Something else that fills my mind when it comes to energy is coffee. Coffee gives me energy to survive the day. So I don't know what you think about when you think about energy, but we are going to talk about the different types and forms of energy that there are out there in the world. So let's get started. So, what is energy exactly? We all have these pictures in our minds when we start to think about energy, but what kind of definition are we working with when we're talking about a scientific definition of energy? So, when we're looking at this, energy is the ability to do work or cause a change in an object, such as the change in its position, its shape, or its state of matter. That sounds a little wonky and it doesn't sound like a very familiar idea. But as we start to talk about the forms of energy, I think you'll start to have a better understanding of what exactly this definition of energy is talking about. So let's get started with some forms of energy. What are some different forms that you already know about? Maybe that we learned about last week? Kinetic and potential energy. If you were wondering why the giant pause, I was trying the Dora thing, but it doesn't work as well when you can't see my excited face after I ask the question. So, potential energy, we already talked about this. This is a quick review. Energy that is stored, right? It's the energy of an object due to its position, shape, or condition. The point of potential energy is that there is the potential for use, right? So, when I think about potential energy, I think about the potential that my cup of coffee has to fill me with joy. I also think about kind of like this bowstring. You can see this archer is pulling back on that bowstring. That bowstring has the potential to release that energy and fly the arrow across like Katniss freaking Everdeen. So that's potential energy. Quick review for you. And kinetic energy is energy in motion. I don't know if you guys ever watched That So Raven. That might not be in your wheelhouse or your age, but there's an episode where she's like obsessed with these like in sync type of guys, and they sing, "Boys, we are the boys in motion. We give you our devotion." And that's what I always think about when I think about kinetic energy. So from now on, anytime you think of it, you can be like, at kinetic energy, energy in motion, you give us our devotion. Or you could just remember the definition instead of singing to yourself. But if you want to liven your life up, that's always an option. So we always think of kinetic energy. It's something's moving, something's going, something's on the move, right? And with kinetic energy, sometimes that kinetic energy can be things that we can't even see moving. So things like electrons, when we talk about electric energy, we can't see them moving, but they are moving. So all of this is under the giant umbrella of the law of conservation of energy. And when we think about this giant umbrella of law of conservation of energy, you might realize, oh shoot, Mrs. Wolf, we already talked about a law of conservation. What law of conservation did we already talk about, family? The law of conservation of mass and matter. We talked about that in our chemistry unit. And now here we are in our energy unit, and it's pretty much the same thing. You just change the word mass with energy. The law of conservation states that energy cannot be created or destroyed, but it can be transferred or transformed from one form to another. But the total amount of energy never changes, okay? And just so you know, We will talk about energy transformations next week. So let's just keep this in the back of our mind as we're talking about the different forms of energy. So, what are the forms of energy? That is gravitational potential, elastic potential, nuclear energy, chemical energy, mechanical energy, electrical energy, light energy, thermal energy, sound energy, also known as Jency melts. My students always make fun of me because they're like, Mrs. Wolf, Jency melts is not a real word, but I will have you know that there is a Build-A-Bear teddy bear sitting in my bedroom right now named Jency Melts, Sir Jency Melts III. So it is officially a real name. So there's a picture of what Jency Melt looks like. And Jency Melts is my acronym to help you remember the different forms of energy. Now, we start with gravitational potential energy and we go all the way down to sound energy. The first 4 types of energy are all potential energy. The last 4 are all kinetic energy. And then we'll have a quick discussion about what we mean when we talk about mechanical energy and how it's stuck between the 4 kinetic and the 4 potential. So, gravitational potential energy. And hey, I'd love for you to write the definitions down of each of these forms of energy if for only your sole need to remember science knowledge. So, gravitational energy is the energy stored. Notice I bolded stored. Anything that is potential energy is going to have that word stored in it. So, gravitational energy is stored in an object due to its height above the Earth. So if it's farther away from the ground, it's got more gravitational energy. If it's closer to the ground, it has less gravitational potential energy. Basically, it's your likelihood of falling flat on your face. If you're standing on the ground, as long as you're not as clumsy as me, your likelihood of falling on your face is low. Your gravitational potential energy is low. However, if you're standing on top of your roof like a hooligan, your gravitational potential energy is extremely great. You have a definite potential to fall on your face, and gravity shall pull you to that place. Little known fact, or very known fact, you won't have any gravitational potential energy out in space because guess what? There ain't no gravity in space. Next, we have elastic potential energy. Elastic potential energy is the potential energy stored when an object is stretched. And no, unfortunately, this does not just apply to rubber bands. It also applies to your pants on Thanksgiving, right? So our pants on Thanksgiving get stretched, and that has the potential to pop, to burst, right? Or to release like a slingshot, right? So when we're talking about elastic potential energy, we're thinking about things stretching and recognizing that they can't stay stretched forever, right? So when we stretch a rubber band, when we release it, you do that kind of flinching thing, right? Because you know for a fact that that rubber band has the potential to hit you in the face, right? So we talk about elastic potential energy, and that is what we're talking about. Nuclear potential energy. When we're talking about nuclear potential energy, it is energy stored in the nucleus of an atom. So what's crazy about this is that really nuclear potential energy has just started to be a thing. When we talk about nuclear potential energy, the only way you can access it is through releasing the energy inside of a nucleus by either nuclear fusion, which is, combining 2 nuclei together, or nuclear fission, which is splitting 2 nuclei apart. So this is something that we, as a human race, just really recently decided to figure out. And it is a very dangerous thing if not done correctly. Nuclear power plants use nuclear fission of uranium to generate some electricity, but it is a pretty dangerous activity. But we're accessing that stored energy by breaking apart the nucleus of atoms. And we have chemical energy. This is my personal favorite because it's the energy stored in chemical bonds and released by the breaking of chemical bonds. Now, that might sound all fancy and stuff, like you have to do it in a laboratory, but your body does it every single day. My body's doing it right now with a half a sleeve of Oreos. Don't let my husband tell you I ate the whole sleeve, because then he would be lying on me and I'd have to divorce him. But I probably ate more than half of the sleeve, probably. So, in our bodies, we take in food, and that gives us some chemical energy to store. And we process that chemical energy and we use that chemical energy by breaking down those bonds through some chemical processes in our bodies. So, our examples of a chemical energy is food. You can also use batteries as chemical energy as well. And even when you burn wood, that's another example of chemical energy being used. Mechanical energy. Now, this is the weird one. We just listed all of the different types of potential energy that are stored and released through other actions. Now, let's talk about the fact that mechanical energy is potential plus kinetic in an object that is used to do work. So, some examples of that is someone running, right? So, the chemical energy in their body is potential energy, but the movement of their muscles is kinetic energy. So, it's the combination of both things in one action. That's our mechanical energy. Now, moving on to our types of kinetic energy. Electrical energy. It's electric. Boogie, woogie, woogie. You gotta feel it. It's electric. Boogie, woogie, woogie. All right. So we're not going to do the electric slide. Instead, we're going to talk about the movement of electrons. Kinetic energy is moving through electrons. It's the movement, like, I don't know. I don't know how to describe movement other than the word movement. But it's the electrons going through the air, doing their thing, doing their do. And the faster that the electrons move, the more electrical energy they carry. So we all know examples of electrical energy. We got outlets in our house, we got lightning in the sky, right? Those are all examples of those electrons moving very quickly. Light energy. So a lot of times students confuse electric energy with light energy. However, there are forms of light energy that do not have to do with electric energy. Best example is the sun. The sun combines a lot of different types of energy. The sun gets its light and its heat from some chemical and nuclear reactions, and it produces light. And when we think about light energy by itself, without electricity, without nuclear and chemical fission and fusion, we think about the movement of photons in waves. So if we just break light down to exactly what it is, not where it comes from, it's all about these little particles called photons moving in waves. And we already talked about light waves being transverse. These waves can travel through space, which is a good thing because without the sun's light, we'd all shrivel up and die. So examples of light energy are pretty obvious: sunlight, light bulbs, and hot objects. Thermal energy. So Gen-C melts. Remember, we're moving our way down through Gen-C melts here. And when we get to the T, we're talking about thermal energy. If you've ever worn any thermal gear, it's meant to keep you warm. And that is because the thermal energy is a kinetic kind of energy. And it's caused by the movement of molecules against each other, which creates heat. Pretty crazy stuff. But you can create your own thermal energy by rubbing your hands together. This sound always makes my skin cringe, though, because it reminds me of being ashy, right? Like having just like really dry skin. But that being said, you can create thermal energy by creating a movement between your hands, and your hands heat up, right? And when we think about thermal energy, that's the warmth of the sun, something baking in the oven, the heat from a heater, rubbing your hands together. And last, but certainly not least, we have sound energy, which is the energy that has brought you this amazing lesson. You're welcome. Thank the lords of the earth, sun, and moon for giving you sound energy, because without it, you would have never heard my amazing voice during this lesson. Sound energy, as we learned previously, is all about vibration. It's the movement of things against each other to create vibrations that travel through the air in longitudinal waves. So we can think about sound energy as things like talking, playing music, clapping your hands. Yay, Mrs. Wolf, we're so proud of you for an amazing lesson. So those are your basic forms of energy. If I were to write anything down, I would write the basic definitions, which, if we're honest, we can just take so I say kinetic energy cause, don't write that. Just write the movement of energy through a substance, okay? Make some summaries for notes for yourself, but get those definitions down, and also take the examples down from this slideshow so that you can have your definitions and examples of each form of energy. That is all I have for you. Good day, good night, good evening, good morning, whatever time you're watching this. And I hope to see you later during class. Thanks a lot.